we have seen that the magnetic field is produced by current, and for steady currents, that means those currents which are not changing with time, it is given as d L prime cross r minus r prime over r minus r prime cubed. This also now tells us the properties of magnetic field. So, this is known as Biot-Savart law, and it is for those cases where d I dt is 0. Now, remember when we were discussing electric field, we said that any vector field can be calculated by its divergence and curl together, give a vector field. So, now if you want to work with magnetic field, it is important to know what the divergence of B is and what the curl of B is. This lecture is going to be concerned with these two quantities. I am going to use a little bit of vector calculus, but I will keep explaining it as we go along. That is necessary, and I would also request you to master this technique, because this will make life very easy while dealing with these fields. So, when I have B r equals mu 0 over 4 pi I d L prime cross r minus r prime over r minus r prime cubed, let us calculate its divergence directly. Divergence of B is going to be mu 0 I over 4 pi, divergence of this quantity d L prime cross r minus r prime over r minus r prime cubed. Notice this is divergence with respect to r, because this is divergence with respect to the r out here, which is where the field is being determined. So, this is with respect to r or this quantity. Integration is with respect to the prime quantity. So, I can actually take it inside and write this as mu 0 I over 4 pi integration of divergence of this vector product d L prime cross r minus r prime over r minus r prime cubed. Now, from the vector identity, the divergence of A cross B is equal to B dot curl of A minus A dot curl of B. We find that divergence of d L prime cross r minus r prime over r minus r prime cubed is going to be equal to r minus r prime over r minus r prime cubed dotted with curl of d L prime minus d L prime dot curl of r minus r prime over r minus r prime cubed. Notice that d L prime is with respect to variable r prime, and this differentiation is with respect to r. So, this term goes to 0. For the second term, recall that r minus r prime over r minus r prime cubed is nothing but minus grad of 1 over r minus r prime. So, this term is d L prime dot curl of grad of 1 over r minus r prime. But what is curl of grad? curl of grad is again 0. So, this whole term comes out to be 0, and therefore, what we find is that divergence of B R is nothing but 0. This is a result we had anticipated in one of the previous lectures by looking at that there are no monopoles or there are no single sources of magnetic field. So, we find from the Biot-Savart formula that divergence of B at any point is always 0. This also means there are no independent sources or sinks of B. Let us see how does that happen. If there was an independent source, then field will be coming out of here, and this divergence of B would be proportional to delta R, or equivalently by divergence theorem, flux through this surface will be non-zero, telling me that divergence cannot be 0. Next, let us calculate curl of B directly. So, this is also going to be mu 0 I over 4 pi curl is with respect to R, integration of dl prime cross R minus R prime over R minus R prime cubed. To calculate curl, I am going to play a little trick. If I take this current loop, a current carrying wire, and show it slightly wide, at any point, suppose I take this point where I am taking dl prime, and this cross section is A. Then I can write I dl prime vector as j at that point, where j is the current per unit area, times A times dl prime vector. dl prime is in the direction of current. So, I am going to bring this vector over to j and define my current density as a vector quantity j r prime A dl prime. What is A dl prime? A dl prime is the volume of this small element, which I am now showing by these shaded purple lines. And therefore, I can write this whole thing as j vector r prime d v prime. All right. So, therefore, I can write B r, which is mu naught I over 4 pi integration dl prime cross r minus r prime over r minus r prime cubed as equal to mu over 4 pi integration j r prime cross r minus r prime over r minus r prime cubed dv prime. Obviously, the integration is over where j is not 0, and that is precisely what how we transferred from that I dl formula to j dv prime formula. Now, let us take its curl. So, curl of B r is going to be mu 0 over 4 pi curl of, again I can take curl inside because curl is with respect to r and the integration is with respect to r prime. So, j r prime cross r minus r prime over r minus r prime cubed dv prime. Now, I am going to use a vector identity, which is curl of A cross B is equal to B dot del operating on A minus A dot del operating on B plus A divergence of B minus B divergence of A. What it means is, let me explain it in the next slide. I have written curl of A cross B as B dot del A minus A dot del operating on B plus A divergence of B minus B divergence of A. You are familiar with this term and this term. What this term or this term means is B dot del means B x d by dx plus B y d by dy plus B z d by dz, and this operates on this vector A, giving a vector quantity. Now, let us substitute for A. I have j r prime. For B, I have r minus r prime over r minus r prime cubed. Therefore, B dot del operating on j r prime, this is a differential with respect to r, j is with respect to r prime, this gives me 0. Del dot B is divergence of r minus r prime over r minus r prime cubed, and thus you recall we have done time and again, is 4 pi delta r minus r prime. Again, a physical way of looking at it is that this quantity r minus r prime over r minus r prime cube is nothing but represents the electric field due to a charge 4 pi epsilon naught in magnitude. And therefore, the charge density is the divergence is the charge density, which is nothing but a delta function. All right. So, that gives you that very quickly. Let us similarly del dot A, which is divergence of j r prime, is also 0. So, when I take the curl of B, which is mu 0 over 4 pi integration curl of j r prime cross r minus r prime over r minus r prime cubed dv prime, curl of j r prime cross r minus r prime over r minus r prime cubed is nothing but equal to r minus r prime over r minus r prime cubed dot del operating on j r prime minus j r prime dot del operating on r minus r prime over r minus r prime cubed plus j r prime times divergence of r minus r prime over r minus r prime cubed minus r minus r prime over r minus r prime cubed divergence of j r prime, and we have found this term is 0, this term is 0, and we are left with minus j r prime dot del r minus r prime over r minus r prime cubed plus 4 pi j r prime delta r minus r prime. This is this term. And therefore, I have curl of B at r is equal to mu 0 over 4 pi integration of minus j r prime dot del r minus r prime over r minus r prime cubed plus mu 0 integration j r prime, that 4 pi cancels, delta r minus r prime dv prime, which is equal to mu 0 over 4 pi minus outside j r prime, this is prime, sorry, dot del operating on r minus r prime over r minus r prime cubed dv prime plus mu 0 j r. J r is the current density, as we already discussed. Its direction is that of the current and its current per unit area. The only term we are now left with to evaluate is this term. To do this, again I will do a trick. So, I am interested in evaluating j r prime dot del r minus r prime over r minus r prime cubed dv prime. When del operates on r minus r prime, it is equivalent to del operating on any function of r minus r prime is equivalent to minus del prime operating on 1 over r minus r prime. All right, so I can write this you can play around with many functions and see that this is true. So, I can write this as integral j, this is r prime dot del prime acting on r minus r prime over r minus r prime cubed dv prime with a minus sign. To evaluate this, I will calculate its x, y and z components separately. In fact, I will do x component, show it is 0, and then you can check the same thing for y and z components. So, x component of this is going to be the minus sign j r prime dot del prime. Since this is a dot product already taken, so there is no x component in this, all three components come. Here I have x minus x prime over r minus r prime cubed dv prime. Let us go to the next page. So, what I am evaluating is integration j r prime dotted with del prime, component I take only of the vector quantity, which is x minus x prime over r minus r prime cubed dv prime. Now, let us look at the divergence of this quantity with respect to del prime, j r prime x minus x prime over r minus r prime cubed. This is equal to divergence of j r prime x minus x prime over r minus r prime cubed plus j r prime dot del prime x minus x prime over r minus r prime cubed, the divergence. If I integrate both sides with respect to dv prime, this is what I get. Notice that this term is precisely what I want. Now, for steady currents, del prime dot j r prime, which otherwise is minus d rho r prime by dt, is 0. Otherwise, it will be minus d rho r prime by dt, but right now it is 0 for steady currents only. If the currents are time varying, this term does contribute, and we will see later that this gives rise to something called the displacement current, but for the time being, for Biot-Savart law, for steady currents, this term is 0. And if the currents are localized, that means far away from the system, they go to 0. This divergence can be changed into a surface integral, and that surface integral will also go to 0, because far away j has really become 0 on that surface. So, what you are left with is the last term, this term here, since left hand side is 0, this term is 0, this term is also 0. So, what I have shown you now if I go back, is that this term here is 0, and therefore, for steady currents, we find that curl of B is mu 0, J the current density R. So, what we have found in this lecture through Biot-Savart law, that divergence of B is 0, and this physically means no monopole, and curl of B is mu 0, J of R. Compare these equations with that for the electric field, where I had divergence of E as rho r over epsilon 0 and curl of E 0. So, here curl of B is non-zero and divergence of B is 0, and remember this is true only for steady currents. If there is time dependent current, then there will be an additional term here which we will deal with later. Right now, we will focus only on magnetostatics and therefore magnetic field due to steady currents.